What are microplastics?
Microplastics are tiny, insidious plastic particles under 5 mm in size that have infiltrated every corner of the planet, from the highest mountains to the deepest oceans. They pose a severe, unseen threat to ecosystems, wildlife, and human health. Photos and imagery often use magnifiers and scientific visualization to reveal the extent of this contamination. Microplastic pollution. Major but invisible microplastics are pervasive, tiny plastic pollutants less than 5 mm found in the air, food, and water, posing a threat to wildlife, ecosystems, and human health through toxicity and inflammation. Key sources include synthetic textiles, tire wear, and the breakdown of larger plastics, leading to their presence in human blood and organs. Mitigation strategies focus on reducing single-use plastics, developing sustainable materials, and improving wastewater treatment to combat their widespread environmental and health impacts. The landscape of microplastic sources. Microplastics enter the environment and human bodies through various pathways. Degradation of larger plastics. Larger plastic items break down into smaller microplastic particles over time. Textile fibers. Synthetic clothing like polyester and nylon shed microscopic fibers during washing and wear, entering wastewater systems and water bodies. Tire wear. The friction from tires on roads releases microplastic particles, which then enter rainwater and water systems. Cosmetics and paints. These industries are significant sources of microplastics, with paints being a major contributor. Packaging and food production. Microplastics are found in food packaging, processed foods, and can even enter via contaminants in water and air. Impacts on wildlife and ecosystems. Bioaccumulation. Microplastics can accumulate in organisms and concentrate higher in the food chain, leading to biomagnification of harmful substances. Ecological degradation. They can disrupt soil fertility, affect plant growth, and impact microbial health, contributing to overall ecological degradation. Environmental contamination. Microplastics persist in all ecosystems, from the deep ocean to high mountain peaks. Risks to human health. Physical damage. Ingested microplastics can cause physical harm and blockages in digestive systems. Chemical leaching. Toxic chemicals from the plastics themselves or adsorbed onto their surfaces can leach into the body. Cellular impacts. Studies on animals and human cells suggest potential links between microplastic exposure and issues like inflammation, oxidative stress, cancer, and reproductive problems. Organ contamination. Microplastics have been found in human blood and deep in the lungs, with potential effects on the heart, liver, and brain. Mitigation and action. Reduce plastic consumption. Banning single-use plastics and choosing biodegradable alternatives are crucial first steps. Sustainable alternatives. Switching to wooden, stainless steel, or glass kitchenware instead of plastic can reduce exposure. Improve waste management. Developing and employing better wastewater treatment techniques is necessary to filter microplastics from water. Policy intervention. Governments need to implement stronger policies, such as the Global Plastics Treaty, to address plastic pollution effectively. Personal awareness. Avoid heating food in plastic containers and consider fresh, whole foods over ultra-processed options to limit exposure. Microplastics enter the environment through numerous pathways. Textiles. Synthetic fabrics like polyester and fleece shed microfibers during washing, which pass through water treatment plants and enter waterways. Tire wear. As vehicles drive, tires wear down, releasing microplastic particles into the air and onto roads, where they are washed into water systems. Personal care products. Microbads in cosmetics and body washes enter the water supply through wastewater. Urban dust. The abrasion of urban infrastructure, including road markings and artificial turf, contributes to city dust that contains microplastics. Agricultural runoff. The use of plastic mulches and sewage sludge fertilizers in agriculture introduces microplastics into soils, which can then be carried into rivers by runoff. Improper waste disposal. Larger plastic litter that is improperly disposed of breaks down over time, creating secondary microplastics. Microplastics have been found in various human tissues and organs, including blood, lungs, and the placenta, though the full extent of their health effects is still under investigation.